The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Thank you for joining today's webinar, Steps to Certification, the Foundation for IoT Device Interoperability, being brought to you by the WiSUN Alliance. Today's speakers are Phil Beecher, CEO and Chairman for the WiSUN Alliance, and Chin Shan Sum, Certification Program Manager for the WiSUN Alliance. All webinar attendees are on mute. If you have a question, please use the question box on the right side of your screen. Questions will be addressed at the end of the presentation. This webinar is being recorded and will be made available on the WiSUN website. With that, I will now turn it over to Phil.
Thank you very much. And thank you everybody for attending this webinar. So the webinar will be in two parts. The content should be shown on your screen. So first of all, we'll do an overview of WiSUN. What is the field area networking profile? Then we'll look at what is the certification program, why test and certify, what are the elements of the certification program, how to get your product certified, and where to test and certify your products. So let's make a start. So what is WiSUN? And I apologize in advance for those of you that have seen this before, but I won't dwell too long. What is WiSUN? So we are about delivering open standards-based, secure, interoperable communications for large-scale IoT, for smart utility and smart city networks. We were established in April 2012. We're incorporated as a not-for-profit organization in Delaware, and we have regional representation in Europe, India, Japan, North America, and Singapore. Over 170 member companies, which include product vendors, silicon vendors, software companies, utilities, governments, and universities. And we're about specifying wireless communications networks based on 802.15.4G and its derivatives, and IPv6, 6LoWPAN, and that's for both field area networks and home area networks. And we define certification programs for multi-vendor interoperable solutions. So the little diagram at the bottom shows we take the RF, the MAC layer, network and security. We create the testing and certification program, and when you complete your testing and certification, then you're eligible to use the WiSUN certified logo and trademark information. So why we were formed? WiSUN goes beyond what IEEE and IETF standards deliver. So those of you that have been involved in the standards process realize that standards quite often contain many options, and that doesn't make it easy to develop interoperable products from those. So WiSUN takes the standards, distills the important information into a communication profile, and then creates testing and certification program from that. So another thing is that organizations such as IEEE 802 and IETF, they create standards, but they don't describe how to test to those standards. Another part of WiSUN is about promotion of standards and interoperable solutions to deliver multi-vendor interoperability for complex ecosystems. So where do we sit? You could consider WiSUN Alliance in a similar way to the Wi-Fi Alliance. So 802.11 is the standard behind Wi-Fi. It's a standard for wireless LAN. It has become ubiquitous in office and home environments, mostly due to the Wi-Fi Alliance creating certification program that guarantees interoperability. And WiSUN is doing the same sort of thing for smart ubiquitous networks based on 802.15.4G. So we deliver communication profile definitions based on open standards for field area, home energy management and IoT wireless networks. We create interoperability and testing certification programs. And those of you that were involved in the early days of SGIP will know that this was termed an ITCA, and WiSUN has modeled itself very strongly on that ITCA concept. Our current focus is about multi-vendor field area networks and home energy management solutions for communications for smart city and smart utility networks. So what WiSUN doesn't do, we're not a standards organization. We serve a different role from IEEE and IETF, and we focus very much on the communication layers and do not get involved in defining application layer. But we do work with other organizations to ensure that application layers will run over WiSUN networks. So our target IoT applications, the utility industry, particularly advanced metering infrastructure, distribution automation, home energy management, smart cities such as smart street lighting, infrastructure management, intelligent transportation and parking management. Then in home automation, smart thermostats, air conditioning and heat controls and energy usage displays. And recently in some M2M activities such as structural health monitoring, there are even some WiSUN deployments in agriculture. So we have 10 promoter member companies who are listed here, who represent a range of target application audience, from semiconductor manufacturers, product vendors, government institutions, module vendors, etc. Our contributor member list keeps growing. I think this is slightly out of date now, but as you can see, we have some significant names here. And then I come to test labs, and some will talk a little bit more about test labs as we come on to it. We have a number of test lab members who are shown here, who have basically labs globally. They're specialized in RF testing particularly. WiSUN goes through an approval process to ensure that labs are 17025 qualified, which means that they're good at testing RF, which is obviously a basis, and all our testing is third-party testing. We have two profile specifications that are applicable for smart utilities and smart city applications. Today's presentation will focus on the field area network, or FAN for short. We have a working group that has developed a specification, a profile spec based on open standards, which you'll see later. And this is chaired by, co-chaired by Cisco and Itron. The current status, we have a feature complete specification approved. It supports 15 4G, 4E, 6 low pan IPv6, and also supports multi-hop through a routing protocol and frequency hopping in appropriate domains. Protocol supports encryption through AES and authentication using 802.1x. And this specification is standardized as an ANSI spec, which is ANSI 4957. In addition, we have a home area networking working group. This is chaired by NICT. The technical editor is Toshiba. We have a specification approved, which describes the communication profile for running an application layer called Ethernet Lite. And that, as you'll see, same support for PHY, MAC, and network layers, different encryption and authentication. And that specification is standardized as a Japanese spec in TTC. So the WiSUN fan use cases, sorry, bear with me. Okay, WiSUN fan use cases. So as I mentioned, the fan is a RF mesh network. If you look towards the lower third of the screen, then you'll see that there's a mesh. The mesh provides connectivity between the end devices. So these could be AMI metering, EV charging infrastructure, distribution automation, things like direct load control, application for SCADA as well, and distributed generation is a fairly recent use case that is very applicable for wireless mesh. In addition, we're seeing more interest in things like outdoor street lighting, traffic management, and parking. So these devices can connect to or become part of a canopy mesh network, and then the mesh will connect into either a private or a public wide area network backhaul, and that could be connected through cellular, WiMAX, fiber, or Ethernet. So brief overview of the protocol stack. I don't need to go into too many details on this. WiSUN is responsible for the lower part of this diagram, which you should see highlighted. This includes the physical layer, which is the RF mesh, the MAC layer, the lower layer, link layer, sub-layer, networking, IPv6, ICMP, RPL, which is a routing protocol, and 6LoWPAN, and the transport layer will provide connections for UDP and TCP. Also, as you'll see on the left side of the green area, WiSUN defines the complete security protocol using EPTLS as the transport layer connectivity and providing certificate-based authentication. So, what is a certification program? Over to you, Sam.
Thank you, Phil. So good day, ladies and gentlemen. In this second part of the webinar, we will talk about the certification program. Typically, we will provide likely answers to likely questions, the typical 5W questions: what, when, why, how, and who, surrounding the certification program. So in the next slide, you will see what is the WiSUN certification program. So I will read this slide, the definition first, and then I will highlight a few keywords and do some elaboration. So the certification program is a process for product vendors to obtain the seal of approval for products indicating that they have met industry agreed standards for conformance and interoperability for one or more of the WiSUN Alliance profiles. So in the second line, you see the seal of approval. After certification testing, if the vendor passes all the tests, then you will be given a seal of approval in the form of a certified WiSUN logo, and then you will then go to the provided the certificates from the for the products. And Phil, can we go back to the last slide, please? Right, thank you. So in the fourth line, what you see is in industry agreed standards, where you will see the list of standards which were presented in the previous slides, all the standards across the different OSI layers of the fan, particularly fan profile, and conformance and interoperability in the same line gives you the different components of the certification testing, and we will explain a little bit on what the conformance component is and the interoperability components is. And finally, of the WiSUN Alliance profiles. So we are particularly discussing the field area network profile today. So this essentially explains what the WiSUN certification program is. Next, please. So in this next slide, what you can see is the relationship between the different profiles, particularly the fan profile and the different OSI layers, as you can see in the boxes with different colors, yellow, blue, and green. So we'll take profile A, for example, a network, fan profile. You will see that the fan profile goes across the transport layer on the top, then goes to the network layer, the MAC layer, and to the PHY layer. Each layer will have a streamlined set of different open standards, and these streamlined open standards will then form what we call a profile. And take note that the application layer is out of scope of the testing and certification. So on the left-hand side, you see a statement mentioning within the scope, which is the transport layer all the way down to the physical layer. In the next slide, what you will see is we will try to answer the question, why should we test and certify? So the reasons to test and certify, we sorted out 6 items here. The first 2 are within the same bundle to ensure conformance of product to the standards whereupon the profile is based. So we mentioned some of the streamlined standards across the OSI layers. So the benefits of testing is, of course, to ensure the conformance of the product to these standards which are attached to the profile, which is the fan profile. The second item is to ensure interoperability. So as we mentioned in the certification testing, there will be a component of interoperability with other products, and that ensures the interoperability of the device under test or the implementation under test with the reference implementations selected in the WiSUN certification program. Bullet number 3 is a member intending to test and certify will obtain the access to our test equipment vendors and also our test facilities to conduct different activities so that they could accelerate the process of developing their products. So that is one of the benefits that can be obtained by engaging WiSUN to do testing and certification. And the fourth point, you will see that participating in PlugFest and testing events. So WiSUN Alliance will organize various events, including PlugFest and pre-test events and so on, so that members can actually meet with each other and conduct different testing to help accelerate their implementation and also help to verify the test specifications and so on and so forth. Then the last 2 items is on more on the marketing part of the certification, the right to use the WiSUN certified logo and able to be listed on the WiSUN certified product webpage listing, which is in the WiSUN webpage. In the next slide, you will see the testing and certification strategy. This is where I will give some elaboration on the 2-part testing mentioned just now, the conformance component and also the interoperability component. The conformance component is for the device under test to be assessed for conformance to the specification, to the test specifications using specialized test equipment or test bed. So in the fan profile, we particularly have a test bed developed in order to conduct this testing. And for the interoperability component is to assess the device under test for interoperability with the reference implementations. So all testing conducted will be by a WiSUN appointed independent test laboratory, which I will elaborate a little bit later in the later slides. And we call this the third-party testing. And then the device under test must pass all the relevant tests to be eligible for applying for the certification. So in the next slide, we will give an idea on what are the elements of the certification programs. So in the past few slides, we actually brought out some of the elements, for example, the test bed, the test specification, and so on. So in the next slide, what you see is actually the details, some of the highlight details of the different components that we have sorted out for the certification program. So there are four: the test method and specification, test laboratory, test equipment, and test bed units. The test method and test specifications are based on what Phil mentioned just now, based on the technical profile. So the technical profile is developed by a group of people in the profile working group, the FAN profile working group. And the outcome of that FAN profile working group is a specification called technical specification or profile technical specification. And the test and certification committee of WiSUN Alliance will take that specification and develop test specification accordingly. So the test specification will then be passed to the test laboratory, our approved test laboratory, so that they can create the test environment. And test laboratories, what is known in WiSUN as approved test labs or ATLs, will also undergo a series of assessment process before they can obtain the status of ATLs in order to deliver the third-party testing. And in order to have to create test environment, they have to also engage with test equipment vendors and also test bed unit vendors in order to work out the test harness. In the FAN profile, it's to create the test bed environment. And of course, in the test bed environment, there are components called the test bed units. I will elaborate these parts more in more detail in the next slides. So now we go into the FAN conformance test bed. So the FAN conformance test bed has three essential parts: the test bed controller, the test bed units, and the Wireshark protocol decoder. So a test bed controller, a script-driven test bed controller, or known as TBC, is to automate the FAN device certification. So the TBC controls the test bed as the certification test plans, all the test cases in the test plan is executed upon a device under test. For the test bed units, we have a total of 14 test bed units or TBUs constituting the test bed. These TBUs are from multiple vendors, and the TBUs implement the API used by the test bed controller. And last but not least, we have also the Wireshark protocol decoder integrated into the TBC and the test bed to capture the traffic. In the next slide, you will see a figure representation of how the test bed controller or the TBC controls the test bed. You can see that the interface between the computer that bears the test bed controller can be connected to the test bed and the devices and the DUTs through a net switch or USB hub or USB to serial adapter. In the next slide, you will see an even more detailed representation of the FAN test bed. So I will direct your attention to the 12 rectangles right in the middle of the figure. Those are the 12 test bed units, what you see device ABC up to device L. So these are the 12 test bed units that act as the router in the FAN profile. And on the upper side, you will see the device LBR Pan A and Pan B. These are the network coordinators. They are the border routers that are controlling the network, and you can see a hierarchical rank 1, rank 2, rank 3, representing different hierarchies of the FAN network. On the left-hand side, you see two boxes which represent the packet sniffer, connect to respective locations to sniff the traffic. On the upper side, the top side, you will see the AAA server and the DHCP v6 server connected to one of the network controllers for certain test cases to be executed. And on the right-hand side, the 3D boxes, you see different device under tests or DUTs. Depending on what roles they are playing, either a border router or a rank 1, rank 2, rank 3 router, they are connected to different places. So all these components will construct what we call the FAN test bed. In the next slide is then we go into the essential part, how to get your product certified. So there is a colorful diagram. You'll probably see these diagrams also in flyers and in the website. So I'll just give you an idea on the three parties involved in this diagram: the product vendor, the test laboratory, and the alliance. A product vendor intending to submit application for certification will first need to engage the test laboratory to conduct certification testing. So before that, there are certain paperwork that needs to be done. So the product vendor is encouraged to engage the alliance to pre-check the submission. So you can contact our officers to pre-check what are the required documents. And after the required documents are pre-checked, the product vendor can then submit a request to the test lab to schedule for certification testing. And normally what the test lab will do is the test lab will engage the alliance to check the standing of the product vendor. If everything checks out, then we go to the second part, which is the testing phase. So that will be a handshake between the product vendor and the test laboratory in placing the order for testing. And then the laboratory will have a certain process for the product vendor to complete, and then the testing will take place. And then finally, it will be the issuance of test report to the product vendor. And the product vendor will submit the report together with all other required documents, which was pre-checked some time ago, to the alliance. The alliance will review all the documents, the application documents and the test report, and verify it with the test lab if necessary. And then if everything goes well, the certificate will be issued at the end of the process. So in the next slide, what you see is just the text that explain essentially what I just mentioned just now. So I will not go through each bullet here. What I would like to add on is that there is actually a document, a policy document for all these steps to be described, and the document can be accessed by members for review and all that. The next slide shows you all the required documents for certification application. So there are a few documents. Most of them are application forms. The first item is a brief introduction on the product, and then item 2, 3, 4, 5 is the protocol implementation conformance statement, the PICS, and then we go to the PICSIT, and there are 2 forms that a product vendor will need to fill in order to apply for certification. So all these are the paperwork which I mentioned in the colorful flow diagram a while ago. And of course, the second last bullet, you see the test reports from the test lab, which is one of the essential documents that has to be submitted. And also not forgetting the last bullet is the information on the product, because after certification is issued, the product vendor has the opportunity to publish the product which is certified on the WiSUN webpage. And for that, we need some information of the product. For example, the link to the product page in the company webpage, the pictures, which is optional, and so on. So the next slide gives you an idea on the steps of issuance of device certificates from the certificate authority. So FAN uses certificate-based security, and please do not confuse this certificate as the paper certificate that we issue at the end of the testing. This certificate is the digital certificate for security protocol, and WiSUN Alliance engages a third-party certificate authority. We call it here CA. So you see 4 parties involved in this diagram. The product vendor, also known as the manufacturer in this diagram, the alliance, the third-party test lab, and the third-party CA or certificate authority. So this process, the issuance of the device certificates process starts with the product vendor engaging the third-party CA to start the process to request for a new account. This account is required when later in time the manufacturer or the product vendor requests test certificates or production certificates So this will then go to the third party's CA, and the third party CA will engage the alliance to check several items such as member standing and check with the test lab on conformance testing requests. And if everything checks out, then the account will be set up by the third party CA, and the account information will be sent to the product vendor. And the product vendor can use that account to do various logistic or management items such as placing order and payment and so on. And then invoice will be sent by the third-party CA. And the last part of it is the certificate request and certificate response, and this completes the process between the manufacturer and the third-party CA in terms of the issuance of device certificates. The next slide shows you where to test and certify your products. So if you go to the next slides, you will see test programs. Here we have the three parts, the physical layer. We show the two profiles, which was shown in the figure explained by Phil a while ago, the fan profile and the home area network profile. So in the physical layer, there are a total of 19 regulatory domains for PHY, but the regulatory domains that WiSUN Alliance starts to work on is the American 902 to 928 band, the Japan 920 to 928, and we're also currently working on the Indian band 865 to 867 for physical layer. For the fan profile, we support multiple regulatory domains globally, but essentially we start preparing the 902 to 928, and we are also aggressively pursuing the Japanese band and the Indian band, which is TBD at this moment, but will be coming soon. In the hand profile, the home area network profile, essentially it is in the Japanese band of 920 to 928. And the next slides will show you the list of approved testing facilities. Here we have the TUV Rhineland USA, which supports the PHY layer, essentially in the 902 to 928 American band. And the fan profile is currently in preparation, also in the American, the 902 to 928 band. TELAC is a test lab in Japan. They support the American 902 to 928 band and the Japanese band, and also the hand profile 920 to 928 band. There's also another test lab in Japan, TUV Rhineland in Japan, supporting the American band and the Japanese band, and the hand profile also in the Japanese band. We also are currently engaging with many other test labs to prepare PHY layer in multiple regions, including the Indian band and other bands. And of course, not forgetting the fan profile, which is also in multiple regions. And the certification, for all the communications for certification application, and if you need more details or discussions, please use this this contact point. And I think that is the end of this part of the presentation.
So thank you, Sam. Now we move on to questions and answers. So I'll drive this bit if everybody's okay with that. So the recording and slides from this presentation will be available at www.wisun.org, and we will send a link to all the participants here. I think we have received a number of questions that have been typed in, and I think probably the easiest way is if I go through and answer these verbally and then type in a summary, if that works for everyone. So the first question is, will WiSUN certification require compliance at all layers or just some layers? So we have a two-stage certification process. The primary first stage is about certifying the radio part of the design, so that includes the RF and the frame formatting in such a way that a company can certify a module or a solution to prove that with the right firmware in it, then it is capable of running the complete profile. And then the second stage is the profile certification, and that would be compliance at all layers. So that's all layers from physical, MAC, network and transport layer, and including the security. So the second question was, will Profile A be a WiSUN certified network? So the profiles that we've mentioned so far were the FAN profile and what we call a HAN profile. So they have a number of similarities. They do have some differences in that the HAN profile doesn't support role ripple routing and uses a different security mechanism. Third question is asking about ANSI and the 4957 specification. So I must admit, I thought this was available from the ANSI web store, but I'll get back to people with an answer for that. Next question. Will there be a hardware abstraction layer implementation test between multiple devices connected to the RF controller? So the TBUs, the testbed units, each has a particular application program interface. So the slide presentation showed that there was a different hardware interface options. The testbed units have an API interface that allows them to be controlled. So basically stimulates them as part of the OpenTester interface. They also integrate the ability to decode received frames. So when one's testing in a frequency hopping environment, for example, then there is a Wireshark style protocol frames that come out of each of the TBUs. So the device under test is actually tested as a black box. So the device is stimulated by RF signals, and then the combination of using Wireshark for some of the single channel tests and using the received frames from the device under test allows you to verify correct protocol implementation. So if that didn't fully answer the question, please do send me some more information. The next question was, does Wireshark have the capability to decode the encrypted packet? So as you're probably aware, Wireshark is a publicly available protocol decoder. At the beginning of this project, we did commission the development of a Wireshark solution that comprises hardware and protocol decoding that also has the capability to insert the keys into decode encrypted packets. But we're envisaging an ecosystem of Wireshark type products to be available for this. We will be sharing the slides. Will all the certified testing be automated or combine manual versus automated? The final goal is for full automation, such that the testbed controller can not only generate the necessary commands through the API to stimulate the testbed units, but can also analyze the incoming received frames and set go, no-go status on that. Will European bands be included in testing? The short answer to that is yes. In the short term, the initial focus is on the 902 to 928 band, which covers North and South America and Korea. Some other countries have a subset of that, for example, Japan. As some mentioned, we are instigating a PHY program for India. The India band is using 865 to 867 megahertz, and there is very close. Hopefully, we will closely follow that with 876 megahertz for your 870 to 876 megahertz for Europe. Question about how long does it take for approval of equipment to be approved by WiSUN? So there is a fee structure for testing with the test labs. That is a topic for discussion between the product vendor and the test lab. So we, as some pointed out, we have multiple test labs. We aim to have at least 2 test labs in any geographic domain, which will give members the opportunity to choose between test labs, which encourages competition. The cost of certifying products from WiSUN Alliance is actually detailed on our website, I believe. But if not, I can provide that separately. Schedule to be able to get end product certification. As some mentioned, we are working on completing the test certification test program, so the testing environment, and bringing the test labs up to speed. It has taken us longer than we were hoping for, but as you're probably aware, it's fairly complicated testing, arranging to test mesh networks with frequency hopping, and we want to ensure that we get this right. So we are currently looking at early Q2 this year. So there's another question which is talking about router manufacturers. So it's currently on the WiSUN website, there is a listing of the devices that are certified for physical layer for FAN. That's probably a good indication of the companies that are likely to go for full certification. So I think checking that out and looking at our member companies is the best way to go for that. So another question is there more than one AMI profile? So the FAN supports a multi-service. So if you can run over an IPv6 network, then the application layer will run over WiSUN FAN. We are supporting, and our member companies do support different profiles. You will have seen or possibly seen recently that WiSUN has established a liaison agreement with the DLMS User Association, and there is currently a work project going on that will look at providing a seamless interaction between the DLMS application layer and the WiSUN FAN communications layer. Next question. How manufacturers can perform tests in the development environment to ensure approval. So we, as a WiSUN member company, you have full access to not only the technical profile specification, but as a contributor member or promoter member, you have access also to the full test specification. The test bed controller devices and TBUs will be made available not only to the test labs, but also to manufacturers. So I would say watch this space for that information. So I'll be looking at certifying optional features in the FAN specification. And when will this be available? So as you will have seen in the overview of the protocol stack, there were a number of options. So as with all interoperability type certification, if we have 2 or more implementations that support an optional feature, then we would introduce that into the test and certification program. So we run a similar situation to that done by Wi-Fi Alliance, where WiSUN staff do a blind poll of the manufacturers and check what functionality that they're planning on implementing, what they're planning on implementing for the optional functions, and then providing there is sufficient interest, we would include that in the certification program. So there was a question about HANS certification here. So the HANS certification program is already established and is running in the test labs in Japan. So that's being implemented by both TELEC and TUV in the Japan labs. We can provide more information offline to that. Sorry, did you say something there, Rolf? Nope.
I did not.
Okay, I must have been wishful thinking. So the questions keep coming. I will keep answering them. Can we say more about the PlugFest process and schedules? And does PlugFest include all layers and security? So the short answer to that is PlugFests are scheduled based on the implementers, so our WiSUN member companies, their schedules for implementing the particular fan. To date, I think we have had 14 or 15 PlugFests for fan. Is that correct, Sam?
Yes, that's correct.
Yep, and they have occurred usually at say 8 to 12-week intervals. More recently, we've been running through some events that are integrating the testbed controller with the testbed units. I think we have so far had either 3 or 4 of those events, which is basically verifying the testbed controller, the activity of the protocol analyzer, and the implementations of the testbed units. But basically, we pick schedules that we try and keep an aggressive timeline going, but give the implementers sufficient time to make progress between each of the events. And PlugFests do include all layers and security. Next question is about test lab in Brazil and certification program. So I think the best answer is to deliver that offline. So we'll have an email associated with that. So one thing that I will come back to is that relates to certification. So as you probably noticed, our testing is all done as third-party independent testing, where the test lab is required to comply with ISO 17025. Currently, certification process is done by a self-declaration and verified by checking the test logs by the WiSUN Alliance. But we recognize that there are end users who will require a formal third-party certification program. So therefore, our certification program is structured in such a way that it's easy to engage with an ISO 17065 type certification body. And you'll probably be aware that TUV, who is one of our test labs, also has a certification body associated. But typically, we could certify, and I'm aware that there are a number of countries that require testing and certification to be done within a national lab, and we are structured for that and are already in discussion with some countries on that. Does certification program cater for the African market? So there are different regions and different regional requirements in Africa. We have been working already in parts of North Africa. I'm happy to answer more of those questions offline. Questions about labs in development and more information about Brazil and South America. As I mentioned earlier, we are in discussion with at least one test lab and certification organization in Brazil, and we are working out the timing to ramp up the certification program with them. So I think I have gone through all the questions that we have received so far. I will answer all of these separately. So Rolf, logistically, how do we go about answering questions? By typing in?
I think you already covered pretty much all of this, so I don't think we need to do any other follow-up. But again, like you said, if people have additional questions, feel free to email us, and we'll try to field them and then go from there.
Okay, so there was one more question came in, which is about the memory requirement required to implement all layers of WiSUN. So unfortunately, that's very much an implementation issue, and I haven't implemented this, so I can't answer that question. But I'm sure some of the product vendors that are looking at these implementations will be able to answer those questions. So that's me all talked out now.
Great, thanks Phil, thanks Don for today's presentation, and as mentioned, the webinar will be posted to the WiSUN website. Thank you for joining.
So thank you everyone. If you have more questions, please forward them to us, and we'll answer them to everyone. Okay, thank you all very much.
Thank you very much. Have a good day.
Have a good day.